Welcome to The Explainer. I am so thrilled you're joining me today because we're going to tackle something literally every researcher faces at some point, turning a totally chaotic mountain of language learning data into crystal clear, actionable insights. Whether you're dealing with vocabulary tests, grammar assessments, or, student motivation surveys, your data can look like an absolute mess at first glance. We've all been there, right? You sit down with your coffee, you open up Excel, you stare at a wall of thousands of numbers, and you immediately just want to close it again. It's incredibly overwhelming. But today, we're getting completely hands-on. We're going to unpack the exact tools you need to build a rock-solid foundation for any quantitative study in English language teaching. We'll figure out how to find the real story hidden inside those numbers. Okay, let's dive into this.
Here is our quick roadmap for today. 1. The foundation. 2. Descriptive versus inferential. 3. Central tendency. 4. Data spread. 5. Visualizing frequencies. And 6. Why it matters. I want you to take a second and imagine that massive, messy pile of raw student data sitting right on your desk. Let's say you've just tested 100 students and you have all their raw speaking scores. It's just a giant spreadsheet. Some students scored a 45, others scored a 92, and you have absolutely no idea what the average proficiency of your classroom actually is. So how on earth do we make sense of that? How do we pull a coherent narrative out of all those scattered individual data points?
Well, the answer lies in the very definition of quantitative research. In ELT research, we solve this data chaos by converting our real-world observations into hard, objective numbers. And honestly, this is essentially a superpower for researchers. By taking something super complex and abstract like learner anxiety or reading comprehension and assigning numerical values to it, we can actually sort of see the invisible barriers to language acquisition. This transformation is exactly what allows us to apply statistical procedures, answer our questions, and definitively test our hypotheses.
Section 1. Descriptive versus inferential, the fork in the road.
So, a really crucial point here is that statistics gives us two very different sets of tools. Inferential statistics, things like your t-tests, ANOVAs, or regressions, are what we use to generalize our findings beyond our specific students to a much larger population. But here is the secret. You absolutely cannot build that advanced inferential house with a rock-solid foundation. And that foundation is descriptive statistics. These are the tools we use to summarize and describe the specific characteristics of the sample data we actually have right in front of us. Let me be super clear about this. If your descriptive foundation is cracked, your inferential house is going to inevitably collapse.
Section 2. Core Central Tendency Measures, Finding the Middle.
We're starting with the heavyweight champion of descriptive statistics, the mean. This is your classic arithmetic average. You just calculate it by adding up the sum of all your observations and dividing by the number of observations. In ELT research, this perfectly represents the central tendency of the data. You're going to see it constantly used to report average vocabulary size, grammar scores, or motivation levels across a classroom. It completely transforms your data into something digestible. But, as we'll see in just a second, the mean is highly sensitive to outliers, which is a really vital detail to keep in mind.
To see this transformation in action, imagine you have 5 students who get speaking scores of 72, 75, 81, 84, and 88. When you add those up and divide by 5, you get a mean of exactly 80. Just like that, you've taken 5 disparate, messy data points and cleanly summarized them into a single, highly useful number. What that 80 represents to a teacher or researcher is pretty profound. It transforms 5 unique individuals into a single, highly reliable benchmark for the classroom's overall performance.
But what happens if one of your students, say, grew up in a bilingual household and easily scores a perfect 100 on the test? That's going to drag that mean way, way up. That's exactly where the median comes in. The median is simply the middle value after you arrange all your scores in ascending order. We need this precisely because it is perfectly suited for data that has extreme outlier scores, scores that would heavily skew a standard average. It's also your absolute go-to metric when analyzing Likert scale responses from student questionnaires, or maybe income-related educational studies where just a few extreme values could paint a totally false picture of the middle. Rounding out our central tendency trio is the mode. This is simply the value that occurs most frequently in your dataset. It's incredibly useful for identifying categorical peaks. Want to know the single most common CEFR language proficiency level in a massive university program? You look for the mode. If you want to know the most frequently selected response on a multiple-choice survey about study habits, the mode gives you that exact answer instantly. It cuts straight through all the noise.
Section 3.
Understanding data spread beyond the center.
Finding the center is great and all, but we also really need to know how far our data stretches out away from that center. The simplest way is the range. You literally just take the highest score and subtract the lowest score. If your top student gets a 90 and your lowest gets a 55, your range is 35. Then we have variance, which measures the average square deviation of your observations from the mean. Now, I know average square deviation sounds like a fancy, maybe slightly intimidating mathematical concept, but basically just think of variance as the essential prep work that gets your data ready for the heavy lifting tests later on, like those ANOVAs or regressions we mentioned. The most practical measure of spread, though, is the standard deviation, or SD. Standard deviation tells us exactly how much individual scores vary around our mean. Think of it kind of like a target. If your SD is low, your students' scores are clustered tightly together right in the bullseye. They're performing very similarly. If your SD is high, those scores are scattered all over the target, spreading far and wide from the average. This metric is so crucial that nearly every single ELT quantitative study published today reports the standard deviation right alongside the mean. You simply cannot separate the two.
Section 4. Visualizing frequencies, bringing data to life.
Raw metrics are powerful, for sure, but researchers and readers also need to actually see the shape of the data. The absolute best way to organize categorical variables, like language background or preferred learning strategies, is through a frequency distribution table. If you're looking at CEFR proficiency levels, a solid table organizes them perfectly. Out of 100 students, you can instantly see the frequency right in the middle. 25 are at A2, 45 at B1, and 30 at B2, with their matching percentages right next to them. It takes a massive spreadsheet of categorical data and just makes it instantly readable for anyone.
But we don't just stop at tables, do we? To truly bring this descriptive data to life, researchers rely on a super dynamic toolkit of graphical representations. We're talking bar charts and pie charts for really clear categorical splits. And why does picking the right chart even matter? Well, a histogram, for example, doesn't just show you numbers, it shows you the visual bell curve of your classroom's abilities. A box plot is absolutely your best friend for immediately spotting that one extreme outlier who maybe just didn't understand the test instructions. And scatter plots? They give us our very first visual hint at how two variables might be correlated. A well-designed chart just makes your descriptive frequencies instantly understandable.
Section 5. Why it matters. The big picture.
If we step back and look at the recent trends in ELT research from, say, 2020 to 2026, the message is incredibly clear. First off, descriptive statistics remain the absolute, undeniable foundation of all quantitative studies. Second, and listen closely to this one, you simply cannot survive in modern high-impact journals with just a basic p-value anymore. Journals are demanding that you report effect sizes, like Cohen's d or eta squared, and rigorous assumption checks for things like normality and variance before they'll even glance at your significance tests. I've literally heard horror stories of fantastic papers getting rejected just because the researchers skipped their descriptive assumption checks. And third, this foundation supports a rapid shift in the field toward highly complex analyses, specifically linear mixed effects models that handle classroom clustering. And guess what? You can't run those models if you don't know your basic descriptive base.
The really good news here is that the tools to crunch these numbers are becoming way more accessible than ever before. While IBM SPS Statistics has kind of been the heavyweight champion for decades in the ELT world, there's this surprising massive shift happening right now. Open source tools like Jamovi, JASP, and the programming language R are totally taking over because they're incredibly powerful and, best of all, completely free. They are gaining huge popularity for calculating these exact descriptive numbers and generating those beautiful frequency visualizations we just talked about, saving researchers literally thousands of dollars in licensing fees.
So as we wrap up this explainer, I really want to leave you with this final thought. It is so incredibly tempting to rush straight into the flashy inferential test to prove your new teaching method worked. But ask yourself, how solid is the data you're actually building on? If you don't know your mean, your standard deviation, and your spread, well, you don't really know your data at all. Never overlook that descriptive core. Take the time to truly master it. Thank you so much for joining me to explore this vital topic, and I'll catch you next time.